In this video, we're going to be looking at homogeneous transformation matrices, and even though we're going to use it to look at the transformation y equals 1 over x into y equals minus 8x minus 44 over x plus 5, which we've already done in a previous video, so if you're interested in more on that, please take a look at the link in the description. Even though we're going to be finding a single matrix which represents this transformation, this video will also be very useful to people who are studying robotics or gaming. So let's just have a quick look at the linear transformation matrices. Okay, this is just a quick summary. So rotation is this matrix here. Stretch is either k001 or 100k, depending on whether you're stretching by k in the x direction or the y direction. And a reflection is either 100 minus 1 or minus 1001, depending on whether you are reflecting in the y-axis or the x-axis. Okay, now the problem is that if we have to have a single matrix which represents this transformation here, and we look at this transformation on this graph, which is source.desmots.com, we can see that the overall transformation is not a linear transformation because, for example, the origin moves, it translates, and therefore we cannot use these linear transformation matrices to find a single matrix which represents that transformation, because there is a translation in it, and the translation is not a linear translation is not a linear transformation. Okay, so what are we going to do is we use a different matrix called a homogeneous coordinate transformation matrix, where we add this extra column here and this extra row here, and the A means a translation by A that way, and the B means a translation by B that way. Now, once we have this translation matrix here, then we adjust our linear transformation matrices. So cos minus sine, sine cos becomes this, where we add 001 here and 001 here. Ditto stretch, where we add 001 here, 001 here. And ditto reflection, where we add 001 here and 001 here. The advantage of all this is that now all of the matrices, translation, rotation, stretch and reflection, are 3 by 3, and therefore when we have multiple transformations, we can multiply the matrices and have one single matrix which is the product of all of the individual transformations. Okay, so with all that explained, let's go back to our question here. So we need a single matrix which represents the transformation y equals 1 over x into y equals minus 8x minus 44 over x plus 5. Now, in actual fact, we've already done this transformation in a previous video, but just to remind everybody what it was is A, we need to reflect in the x-axis, so that was basically replacing y by minus y, so that became here minus y equals 1 over x, or y equals minus 1 over x. And the second thing we did was we translated it 5 that way, which meant that x was replaced by x minus 5 or x plus 5, i.e. y equals minus 1 over x plus 5. And then the third thing we did was we stretched it 4 in the direction of the positive y-axis, i.e. y becomes equal to y over 4, which means i.e. y over 4 equals minus 1 over x plus 5, which equals, y equals minus 4 over x plus 5. And then the fourth thing we did was we translated it 8 down that way, which means that y becomes equal to y minus 8, i.e. y plus 8 equals, let's just get a bit more space here, minus 4 over x plus 5, or y equals minus 4 over x plus 5 minus 8, which is the same thing as y equals minus 8x minus 44 over x plus 5. That's the same thing. So these are the 4 transformations that we need to do. Okay, so what we're going to do is we're going to put those all in matrix form. So let's write A. Transformation A is going to be the matrix, we're reflecting it in the x-axis. So that is going to be 1, 0, 0, 0 minus 1, 0, 0, 0, 1, which if we go back over here, the reflection is that one there. Okay, so that's A. B, the translation, the translation of 5 in the direction here is going to be 1, 0, minus 5, 0, 1, 0, 0, 0, 1. And that is this one here, putting A as minus 5. And then C is the stretch of 4, and that's going to be 1, 0, 0, 0, 4, 0, 0, 0, 1. And that is going to be, sorry for keeping on scrolling here, that is going to be that one. Sorry, that one. Because we're doing the 3 by 3, aren't we? And then finally, D, which is the translation 8 down, we're going to use this one again, save me scrolling. So D will be the translation 8 down, which is going to be 1, 0, 0, 0, 1, minus 8, 0, 0, 1. So we have our 4 matrices, and what we need to do is we need to multiply them all together in the correct way. We need to multiply. So let's call this matrix here A, and this one here B, and this one here C, and this one here D. What we need to do is because first of all we do the reflection, so therefore what we would have to solve is D, C, B, A, where we're multiplying the matrices in that fashion. Okay, and then what we can do is we can apply that to the coordinate x, y, 1, and that will give us our transformed matrix. Okay, so let's do B times A first. Let's go B times A. Well, B times A, you have to be able to multiply 3 by 3 matrices, but just doing that gives us 1, 0, minus 5. 0 minus 1. Fortunately, there's a lot of zeros in here, so multiplying it is actually not too hard. So that's BA. And now what we have to do is we have to multiply BA by C. So C times BA, and that gives us 1, 0, minus 5, 0, minus 4, 0, 0, 0, 1. Again, if you don't know how to multiply 3 by 3 matrices, check out our video on that topic. And then what we have to do is we have to multiply this by D, so D times CBA, and let's just write this one out full. That one is 1, 0, 0, 0, 1, minus 8, 0, 0, 1. That's D there, multiplied by this product here, 1, 0, minus 5, 0, minus 4, 0, 0, 0, 1. And that gives us the answer, which is 1, 0, minus 5, 0, minus 4, minus 8, 0, 0, 1. And that is the single matrix which represents, oops, sorry, gone too far, which represents this transformation here. Okay, now let's just check that, because we do need to sort of prove it. Why don't we take 2 points, and well, first of all, let's prove it by putting in the parametric coordinates. So we have y equals 1 over x, so I let x equal t and y equal 1 over t, that's parametric coordinates, and let's apply that 1, 0, minus 5, 0, minus 4, minus 8, 0, 0, 1. Let's apply those coordinates, t, 1 over t, 1, and this is basically just the dummy, which allows us to multiply translation matrices by other linear transformations. And let's multiply this one out, and that gives us t minus 5 minus 4 over t minus 8 and 1. So therefore we know that x equals t minus 5 and y equals minus 4 over t minus 8. And then when we get rid of the t, we will get, so therefore t equals x plus 5, and sticking that into there, we get y equals minus 4 over x plus 5 minus 8, which equals minus 8x minus 44 over x plus 5. So we have shown that using the parametric coordinates, that indeed this matrix here does convert the parametric coordinates, which are y equals 1 over x, x equals t, y equals 1 over t, to the correct curve, y equals minus 8x minus 44 over x plus 5. Now, just for those who are still a little bit dubious, why don't we just check with, say, a random point? And rather than just taking the point 1, 1, which is a bit easy, let's take a slightly different point. Let's take the point 2, half. Okay, now, so we got the point 2, half, and what we're going to do is we're going to apply the curve 1, 0, minus 5, 0, minus 4, minus 8, 0, 0, 1 to the point 2, half 1, and this is just a check. I mean, we've already done this with the parametric equations, but for those who like to see it in reality, that gives us -3, -10, 1, and so therefore the point 2½ on the curve y equals 1 over x is transformed into the point -3, -10 in the curve y equals -8x -44 over x plus 5. Now what we can do is, using these four, where are they, the four here, and I think I'm going to have to go into a different colour pen, otherwise you're not going to be able to see it, so let's go into red. Okay, so we're in red now. So what we're going to do on the point 2½ okay, first of all, let's reflect it in the x-axis, and we need 2½ according to the matrix. 2½ goes to the point -3, -10. Well, let's see if it actually does go to the point -3, -10 by going through each of these four transformations. Reflecting 2½ in the x-axis, all that does is flip the y, so that gives us 2 -1/2. Okay, and then if we translate 5 that way, that just takes 5 off of the x, which gives us -3 -1/2. And now if we stretch it by 4 in the y direction, well, that just multiplies the y by 4, so that gives us -3 -2. And then if we translate 8 down, well, all that does is take 8 off the y, which gives us -3 -10, which indeed is exactly what the matrix predicted, and so therefore we can be pretty confident that this matrix here is the single matrix which explains, or which basically equals the transformation of this curve here into that curve there. Very useful for robotics and gaming, like I say. I hope you found this useful. If you did, please like this video by pressing the little thumbs up button and subscribe to the Grassy Academy YouTube channel. Thank you.